Now we'd like to hear Professor Franco Canestrari, a lecturer in biochemistry and molecular medicine at the University of Urbino. The title of his talk is the Hypoxia, Warburg Effect and Degenerative Disease. The role of hypoxia in proliferative cell damage. Thank you very much. Special thanks to Giorgio Tiziani, and I'll tell you why. Because he has grown our experience. He gave us cell food and said, right, try it. So for those of us who are involved in basic research, testing means gaining experience. So I'd like to thank him for the opportunity to carry out this experiment. I've seen the amazing results of cell food, which will be dealt with later on. The first part of my talk, the theoretical part, but the more practical part will be tackled by my younger colleague, and mine is a theoretical approach. It's a great opportunity for me to be here today because when we talk about the Warburg effect, we're talking about two main antagonists, because I am a biochemist by training. We have Warburg, who argued with Krebs in the past, and Krebs was involved in the Krebs cycle, so you can imagine the contrast they had in the past. So I'd like to pay tribute to these two colossal figures of biochemistry. I wanted to start with, I've tried to remove some of my slides because I don't have enough time and I'll have to monitor the time today. So basically, all of us need to gain information, those of us involved in basic research, because information is a synonym for prevention. The air we breathe, the food we eat, the water we drink are all virtually made up of water, and we never think about this. Appropriate exercise, correct posture, and the environment we live in, our thoughts, our emotions. You will realize that around 30 years ago, if you remember, the discovery of opioids opened the field of psychoneuroendocrinology, and the discoverer claimed that being a woman, she did not receive the Nobel Prize, and this led to controversy, but it opened the way to psychoneuroendocrinology. Plainly, oxygen, water, optimal diet, emotional equilibrium, this famous psychoneuroendocrinoimmunology, what this means that we cannot think that the origin of the story is simply this, simply stress, depression, including oxidative stress, including environmental depression, the immune system. We cannot simply that these factors are responsible for the onset of disease. This is a very complex network, but I started off with the PNEI, this psychoneuroendocrinoimmunological approach, because in the past it was thought that this was responsible for regulating thrombosis, and now we know that this is involved with thrombi taken from the intestine and carried throughout the circulation. More anguish for basic researchers means that the more we investigate cells, the more we enter into depression ourselves, looking at the complexity of the synthesis. So talking about oxidative stress and hypoxia, but they don't realize quite how complex the phenomenon is when we look at it at molecular level. The further we move on, the more complicated the topic becomes. So with great humility, we have to address the terms of hypoxia and oxidative stress. Oxygen is plainly equal to energy and equal to ATP, which always comes into the picture. Glycolysis is involved in energy generation, as are the mitochondria, to give us the energy required. A reduction in the amount of energy immediately creates problems at cell level. So as soon as ATP drops at cell level, this triggers a whole series of complex mechanisms, and all processes occurring in cell sites are actually effects resulting from a reduced energy rate. Oxygen is also a source of free radicals. As soon as we are born, our first breath is the first source of oxidative stress. You can imagine in a lifetime how much we accumulate. But oxidative stress, we're interested in the mitochondrial stress that can be evaluated. And you can see how much there is in this slide from all sources of stress. We focus on mitochondrial leakage of electron transports in the mitochondria, but the sources are many. Oxidative stress is the consequence of a disequilibrium among pre-oxidative and antioxidant processes, and this needs to be remedied by antioxidative mechanisms. For example, when our antioxidative defenses are down, then we can get flu, for example. So once doctors used to say to flu patients, stay still, go to bed, keep warm, because that would limit their energy expenditure, then this may, and then add in fresh orange juice and aspirin. So this is always been a key factor in regulating homeostasis. When balance in our lives between pro-oxidant factors and antioxidant factors is disrupted, then we see what is seen in the cartoon, which is this oxidative stress. We have been, unfortunately, investigating cancer because among the many investments that have been made, I won't go into political discussion here, but we have had major results, but that has also aroused many, many doubts and problems to do with chemotherapy. First of all, we need to understand the problem before we can take action. So oxidative stress is involved in neoplastic and metastatic processes, and mitochondrial oxidative stress is the prime culprit. Here we saw that if we work on SOD, written in right, the antioxidants, then there we can help to balance the system. So this process strongly involves mitochondria, first and foremost. And this raises a whole series of problems, because we will have DNA damage, we'll have autophagy, mitophagy. We need to find energy because the neoplastic cell is greedy for nutrients. So autophagy means it will demolish itself just to reach a nutritional and energetic equilibrium. ROS and tumoral progression. Here you can see this recovers what we said. The free radicals in oxygen are implicated in all DNA processes and growth factors, cell motility, angiogenesis and inflammation, and the activation of oncogenes, and in ultimate analysis, mitochondrial damage, the Warburg effect. Moving on, this emphasizes the previous slide, because we say that ROS are at the focus of our ascension because they modulate all cell mechanics, and we see that they are responsible for cell response to all events. Here we see recently we're also talking about a transcription factor that I've written in red, HIF1A, which has opened new fields of knowledge, because these transcription factors are simply small proteins or peptides which communicate with genetic material, so they are a sort of shuttle service for information. All these transcription factors are involved at nuclear levels, so according to the information they receive, they will respond with cell death or apoptosis and a whole series of strategies. So in the end, I'll jump this because this is a bit futuristic, but one of the main problems today is to what extent is exercise a paradigm for hormesis? we will never really be able to give a plausible answer to this, because as individuals we are involved in geometrics. We need small doses, because small doses can give small responses. So a very high dose of antioxidants in certain individuals, we could shut the window and that individual is no longer able to respond with his own endogenous immune systems. So we need to take into account the fact that man is highly adaptable and has his own endogenous adaptive mechanisms. So at point of danger, he risks not being able to use his own genes to fight insults and possible disease. So this needs to be said. We are hormetic individuals. Physical exercise is an example I always make, because it's obviously physical exercise is extremely important. It generates ROS, but at the end of the day, if exercise is prolonged and recurrent, it has a beneficial effect, because it wakes up genes which have an antioxidant effect. So looking at the next slide, protecting us from childhood, from adolescence. With physical exercise, it will have a protective effect from childhood onwards, creating a responsive effect to disease. So sport is important during childhood, because we know that future patients which have started getting ill way back in their childhoods very often. So a sedentary lifestyle will start the devastating effects of free radicals and lipids on the vessels, leading to atherosclerosis. So prevention must start with primary prevention early on. Another example here, we have hyperbaric oxygen therapy, but the opposite of oxygen therapy is hypoxia, which will often be able to help people with a lack of oxygen, for example, deep-sea divers who are put in a barium chamber to save their lives because of loss of oxygen. So I give the examples of lack of oxygen and hyperoxygen, because both can create free radicals. Now moving on to hypoxia. To focus on the main topic, hypoxia is a condition in which a cell finds itself when it does not have enough oxygen. This will mean that oxygen is the main actor in this pathophysiological diagram. So the trinity of normoxia, hypoxia and hyperoxia are a trinity of conditions. So here we can see that oxygen will stabilize this protein, this HIF1A, to make it into a transcription factor. Not looking at the complexity of the diagram, this means that within the ROS, the HIF is stabilized to allow transcription. When oxygen is inserted, HIF becomes a positive factor which is broken down by the cell, and we enter into equilibrium. So depending on the presence or absence of oxygen, the protein will enter the cell with information and be broken down. So oxygen here is the major factor in pathophysiological equilibrium. Hypoxia, from a recent research study, hypoxia is linked to tumor development. It favors the transition of cells from the epithelial state to the mesenchymal state. This means that hypoxia, the Warburg effect, is a transformation into tumor cells with staminal cell-like features and the potential to invade non-neoplastic tissues. So basically hypoxia, this transcription factor, has the role of informing forming the cell to carry out angiogenesis or motility or plainly metabolism, so that tumor cells are greedy for glucose, so glucose transporters will be activated. There will be a Warburg effect with all the devastating results that has. There will be changes on cytochromo oxidase and on the Krebs cycle, which is the start of the story and the end of glycolysis. And in the end, there will be accumulation of lactate and carbon anhydrasis and a loss of pH. And so often the recommendation is to take bicarbonate of soda in the evening and recognize the Warburg effect to try and offset the acidity which is created. We need to recognize Warburg's work. Many papers have come out in the last 5 years on his research into the prime cause of cancer. Any biochemist who doesn't know Warburg is ignorant of major information in the sector. He discovered a major relationship between glycolysis and cancer. Recent papers have shown that this HI1F1A factor will demolish the metabolic shift because it activates an enzyme, a mitochondrion in this case, on which the glycolytic pathway depends, recovering energy from oxygenation. So here we see what happens because apoptosis decreases, whereas cell proliferation increases, and this apparently insignificant step opens a new world of research which we are currently focusing on, because this would lead us to understand how an enzyme pathway is blocked and then the cell is confused. It doesn't know whether to go into apoptosis or proliferate. So you can see that this is a crucial point in research. This is the point we are currently studying thanks to cell food. This is the current fascinating focus of research. And moving on to metastases, I just wanted to show you that recently different hypotheses have been put forward to explain metastases. It's sad to say this because we're talking about tumors, but we want to take away this demonization of metastases, because recent studies that have been published this year have put out a hypothesis that tumor development means new tumor tissue. Metastases mean that tumors enter into the circulation and try and reproduce tumors elsewhere. So a new approach to metastases show that if a tumor has to respond to oxidative damage, then a metastasis can be an escape from this oxidative stress. This is the hypothesis. So it may well be that rereading this, the metastatic cell is simply a cell in crisis because due to oxidative damage, and is looking in some way to escape, and I can show this in the next slide. Here you see the cell movement induced by this transcriptor HIF is using free oxygen radicals to then become a pathway searching for oxygen. So this is the initial step in tumor replication. Shows that cells are responding to mitotic. Tumor cells are proliferating, and metastases are the first response in this cycle. So it's an escape pathway. And in this escape pathway, plainly, the cells have to find another microenvironment favorable to development. You know that cancer is a disease that is studied by evolutionists because it's part of the evolution of the species, and hence it's important to understand the mechanisms. Oxidants use signals in molecular biology by identifying the role of free oxygen radicals in cell dynamics. The tumoral pathway is completely unfavorable to cell growth. It attacks immune mechanisms because it's not that simple for tumor cells to survive, because the immune system is vigilant and with its natural killer cells tries to throw the tumor cells out. Hypoxia is also unfavorable, and oxidative stress, again unfavorable to tumor cell development, because we have metophagy and autophagy, because where the cell lacks nutrients, it will not survive. So at the end of the day, by revisiting metastatic cells, we can see them as unicellular organisms trying to escape from a terrifying scenario created by antioxidant factors. Generally, they're seen as aggressors, but we need to re-examine them in the framework in which they are unfavorable cells which are threatened by the entire organism and desperately trying to reapproach their tissue and their homeostasis. So this fear that is currently generated will simply trigger the systems we talked about at the beginning. So for all those patients who have to live with cancer and with tumors and the production of strange metastatic cells, the self-curing pathways, which are extremely rare, but they do exist, these have never been demonstrated, but they must obviously have activated their own defense mechanisms living alongside neoplastic attack. So instead of attacking neoplastic cells, which often has dramatic negative results, it might be better to study the metabolism of metastatic cells and neoplastic cells to then try and understand the dynamics of cell development, which has been neglected to date, to join the band of aggressors, and so much study has focused on anti-neoplastic drugs, but very little has been focused on the Krebs cycle, on the Warburg effect, and on metabolism, because if I don't know the basis, then many drugs will not be effective. So first we need to understand the enemy and its metabolism, and then in the second stage understand how we can keep the enemy at bay. So to end, the other thing I wanted to show you, and according to a great philosopher of science, science consists in periods of normality during which scientists continue to sustain their own theories, even though they have noticed abnormalities, and then interspersed by great periods of change. Finally, something new will emerge. So, seeing that Everett Story, who could see that he'd be of use to humanity and returning to revisit biochemistry and deuterium and cell metabolism, we need to understand that when we don't know something, our curiosity should lead us to study it further. There's a dearth of curiosity in the modern world, but we need to follow the Everett story that we will hear later. And to end, I wanted to end with Einstein's theory that the mystery of eternal life, consciousness, and the wonderful structure of the world we live in together is the incessant energy to understand a particle, however small it may be. And I also added that when you are with your love for 1 hour, it's like a second, but when you're with someone who gets on your nerves, it sounds like a lifetime. So this is what I wanted to add. I will end here and thank you all, and I hope I was clear.
Grazie, Professor
Thank you, Professor Canestrari.
I particularly appreciated, being a sociologist, your quotation from Kuhn, a philosopher of science, who believed that it was extremely hard to change a paradigm and that all scientists are quite conservative. But very briefly, you demonstrated that metastatic cells that are now considered as aggressive could be reconsidered and interpreted as energetically weak cells, according to the Warburg's effect. And a desperate attempt at escaping from a hostile environment